Okay, here's warm-up number 22. So we're going to name the vector in this diagram. So a vector looks like array. It's kind of similar to array, but it has a particular direction and length. So the length of it actually ends at the end of the tip of that little arrow. It doesn't go on forever, okay? So naming this arrow, some people are going to say, oh, I'll name that KJ, but that's incorrect because this is called the end point. I kind of think of it as the start, but that's actually called the end point, and you got to start with the end point. So this has to be JK, okay? And you can write out the word vector if you want, but the little symbol for it is an arrow, but notice the hook only has the top part of the hook there. So this is vector JK, not vector KJ, okay? And writing the component form, that describes how you get from the end point to the end of the arrow, okay? So what we're gonna do is think, well, first you do how far left or right you go. So I'm gonna go left 3, so I'm going to think of that as -3 to indicate that I went left 3, and then I'm going to go up 2 units here. Okay? And then it looks like an ordered pair. So you're going to do the left-right first, then the up-down. Okay? Now instead of just putting the normal parentheses around that, though, we're going to use these brackets. Okay? So that's telling me that this is a vector, not just an ordered pair. Okay? And that is component form. Okay? All right, next up, write a rule for a translation from SRT to, and these little apostrophes mean this is SRT prime. So it's S prime, R prime, T prime, okay? And prime means it's after the transformation. So that means my solid one here is my original triangle, and this is after a translation, which is a type of transformation. It's a slide, basically, okay? So writing a rule for this, what I want to do is I want to say what's happening to the XY pairs. Okay, I could make a vector and say how far everything went right and up, but that wouldn't actually be a rule. A rule is always going to be in this format. Okay, so I'm going to say, okay, let's take one of my x's. So let's take point S because I can see that one's actually right on the grid here. So if I look at point S, this is at -2, -1. Okay, and if I look at S prime, that's at 1, 1, right? Okay, so if I'm going right, I would go right 3 units, okay, and then up 2 units. So I'm going right 3, up 2. And the same would happen with R or T. It doesn't matter which one you choose. I just chose that because those are both on the right on the grid, not like halfway between, okay? All these points would go right 3 to the up 2. Right 3 and then up 2. So if you take your X and add 3 to it, all right, if I take -3 and add -2 and add 3, that'll put me at +1, okay? And then all of the y pairs, the y represents the height, so my heights have all been shifted up 2. So I'm going to add 2 to the y's, and there is my rule, okay? If you put this, you could also do a vector for this. You could describe this transformation with a vector. It would look like this, but that's not a rule. A rule is going to be this, okay? All right. So here we've got a rule again. We're going to find the image of 5, 9. Okay? So if we're finding the image, okay, so that means that this must be the pre-image. Pre-image means it's going to be the starting figure, and the image is after the transformation or translation. So this here would be my pre-image. This would be my image, okay? All right. So this is pretty straightforward here, okay? I've got this rule, and I'm just going to plug in the x and the y. Because I already know what the pre-image goes right here, right? This is my pre-image, and this is my image. Okay, so 5, 9, I'm going to put in here, and that means I'm just going to plug in a 5 for the x, and I'm going to plug in a 9 for the y. Okay, and then I'm just going to do the actual arithmetic here. 5 minus 3 is 2, and 9 plus 1 is 10. So, you know, after you take this and shift everything left, shift left 3, up 1, that'll put you at the point 210. You could plot it out on a graph and try it out. That would work like that. Okay, now it gets a little trickier when we're asked to find the pre-image. So we're finding the pre-image. That means that this must be the image. Okay, so I'm going to recopy this rule here. Okay, so remember this is going to be my pre-image. I'm just putting PI for pre-image, and this is going to be my image. Okay, all right, so this time I know the image. So the image is going to be 47, so I'm going to put 47 in this slot. Okay, and then what I don't know is the pre-image, so I'm just going to put question mark, question mark. That's what I'm looking for. Okay, so what I can do now is I can use the rule here, okay? So x minus 3 should be equivalent to 4, and y plus 1 should be equivalent to 7. So now I'm going to write two separate equations. I'm going to write x minus 3 equals 4, and I'm going to write y plus 1 equals 7, okay? And then these are pretty straightforward to solve. I just add 3 to both sides here. I'm going to subtract 1 from both sides here. So x equals 7 and y equals 6, okay? And that means that pre-image should be the point 7, 6, okay? Now there's another way to do this which is a little bit quicker, but I find people have trouble remembering when to do this, okay? So, and I'm trying to show you why this happens too. So let's go back to this problem. And when I realize that this is the image, this is the final one, I can just use the rule backwards. So instead of, instead of adding 1 to the y, I'm going to subtract 1 because I'm moving back through this rule. So 7 minus 1 would give me 6, right? And then 4 plus 3 is going to give me 7. So when you're finding the pre-image, you're going to go backwards through the rule, and that means you can do the opposite of what the rule tells you to do. Instead of, subtracting 3 and adding 1, you would add 3 and subtract 1, okay? But it's really easy to mix up, so just be careful if you're using that shortcut, okay? All right, that's it. See you next time.